Welcome to the Deep Dive. Today we're plunging into the world of Thescelosaurus.
That's right, a dinosaur from the very end of the Cretaceous, found in western North America.
We've gathered quite a bit of material on this one classification, what it looked like, its discovery, how it lived, all based on the scientific literature. And our mission really is to pull out the most interesting bits about this dinosaur. Its name means marvelous reptile, which is pretty cool.
It is, and it was also kind of overlooked for a while, which is part of its story, too.
Exactly, the neglected part of its name, which we'll get into. We want to give it its due today.
Sounds good. Where should we start? Maybe its place in the grand scheme of things. Classification.
Yeah, let's pin it down. Where does Thescelosaurus fit in the tree of life?
Okay, so broadly, Eukaryota, Animalia, Chordata, then Dinosauria, of course.
Right.
Within dinosaurs, it's an ornithischian. And more specifically, we place it in the family Thescelosauridae, subfamily Thescelosaurinae.
Got it.
The genus itself is Thescelosaurus, named by Gilmore back in 1913.
Thescelosaurus gilmore, 1913. And the main species is T. neglectus, also 1913. But I gather it's not just that one species. There's been some debate.
Oh, definitely. Besides T. neglectus, there's T. edmontonensis, though that one's generally considered a nomen dubium.
Nomen dubium, like doubtful name.
Exactly. Means we're not quite sure if it's really distinct based on the fossils we have.
Yeah.
Then there's T. garbonii and T. infernalis. That one's also a nomen dubium.
Okay.
And T. infernalis actually used to be called Buganosaura.
Buganosaura. What's the story behind that name? Sounds interesting.
It means something like large cheek lizard. It was based on some features thought to be unique at the time.
Ah.
And then there's also T. assiniboensis. So yeah, the family tree has had a few branches added and pruned over the years.
And the name Thescelosaurus itself, marvelous reptile, and neglectus.
Meaning neglected or overlooked, which is, well, quite fitting given how the first big discovery was basically forgotten for years.
It really is. Like, its name predicted its early scientific career.
Kind of, yeah. Gilmore might not have realized how apt it was.
You said Thescelosaurus is the eponymous member of its family, Thescelosauridae. What does that imply?
It means the whole family is sort of defined by Thescelosaurus. It's the benchmark for that group. But where that group fits overall is still debated.
Oh.
Yeah. Some studies put Thescelosauridae as basal ornithopods, sort of early offshoots within that big group of bird-hip dinosaurs.
Okay, like near the root of the ornithopod branch.
Exactly. But other analyses suggest maybe they're outside Ornithopoda entirely, still within the larger group Neornithischia, but maybe, doing their own thing evolutionarily.
Fascinating. So, marvelous, neglected, and a bit of an evolutionary puzzle.
Yeah.
Right, let's picture this thing. How big was an adult Thescelosaurus?
They were moderately sized, generally, maybe 3 to 4 meters long. That's about 10 to 13 feet.
Okay.
Weight-wise, probably in the ballpark of 200 to 300 kilograms, so 440 to 660 pounds.
Right. Not tiny, but not a giant either.
No, though T. garbani might have been a bit bigger, maybe pushing 4.5 meters. And there's a hint, just a hint, of sexual dimorphism, males and females, perhaps differing slightly in size.
Interesting. And how did it get around? You see pictures, usually on 2 legs.
Primarily bipedal, yes, walking on its hind legs. And it had this long tail, maybe half its total length.
For balance.
Exactly. But it was also stiffened by ossified tendons. Think of them like bony rods running along the tail vertebrae.
So not whippy, more like a rigid counterbalance.
Precisely. Helps stabilize it. Its limbs were quite robust, sturdy, and interestingly, the thigh bone was longer than the tibia, the main shin bone.
Like that means?
Well, usually in fast runners, the lower leg is elongated relative to the upper leg. Since the Thescelosaurus had the opposite, it suggests it wasn't really built for speed. More power, less velocity. A sturdy walker.
The sturdy walker. Okay, what about the head? What did the skull look like?
It had a pretty long, low snout, and at the very tip, a toothless beak.
A beak like some other ornithischian.
Right, but behind the beak, it actually had more teeth than many of its relatives, and different kinds.
Oh, like specialized teeth.
Seems like it. Up front, in the premaxilla bone, it had these small, pointed teeth. 6 of them, which is actually considered kind of a primitive feature.
Okay.
Then further back, in the main upper jaw and the lower jaw, it had these leaf-shaped cheek teeth, good for grinding plants, and lots of them, up to 20 on each side, which is also, quite a few compared to some later ornithopods.
So a beak for snipping, maybe?
Yeah.
And then lots of grinding teeth. Anything else distinctive about the skull?
Yeah, there were these bony ridges on the outside of the jawbones. Some scientists think these anchored muscular cheeks.
Cheeks. to help keep food in while chewing.
Exactly. Helps process plants more efficiently. And it also had these heavy, bony structures over the eyes, palpebrals, like built-in bony eyelids, probably for protection.
On the eyelids, that's cool, like natural goggles.
Sort of. And T. acinamboensis, that other species, had some unique skull features too, especially in the brain case area, like an extra opening up top.
Interesting variation. Okay, moving down the body. What about the spine and ribs?
T. neglectus, the main species, had 27 vertebrae before the hips, that's neck and back combined, and 6 fused together in the hips, the sacral vertebrae.
6 sacrals.
Yeah. The T. acinamboensis specimen maybe only had 5, but that one might not have been fully grown, so it's a bit uncertain.
Okay.
The rib cage itself was quite broad, indicating a pretty wide body, and it had these unusual plates between the ribs, large, thin, bony things called intercostal plates.
Intercostal plates, what do they do?
That's the million-dollar question. We're not entirely sure. Maybe something to do with breathing mechanics, or maybe just making the chest cavity more rigid. What's interesting is they seem to ossify, turn to bone later in life.
So younger ones might have been a bit more flexible there.
Possibly, yeah. It's an intriguing feature.
Definitely. What about hands and feet? Any specializations?
The hands had 5 fingers. The middle one, the second finger, technically was longest. The pinky, the 5th finger, was really small.
Did it have claws?
The first 3 fingers had these sort of blunt, hoof-like claws called unguals.
Okay. And the feet?
Feet had 5 metatarsals, those midfoot bones, but only 4 toes actually touched the ground and bore weight. The 5th was just a tiny vestige.
Like our pinky toe, almost useless.
Kind of analogous, yeah. The 3rd toe was the longest, and the toe bones themselves, the phalanges, were quite flattened.
Flattened toe bones. Wonder why. Maybe walking on soft ground.
Could be. It's one of those details we're still figuring out. Oh, and T. garbani had a unique ankle structure too, with a reduced heel bone, the calcaneus.
Lots of subtle variations. Finally, before we move on, what about skin? Feathers? Scales? Armor?
Integument. For a long time, that was a big question mark. Gilmore noted some carbonized bits with a weird texture, but nothing clear.
Right.
There was an early idea, even suggestions of small bony armor plates, scutes, but that's been largely disputed. Some think those bits might have come from a crocodile fossil found nearby.
Contamination.
Possibly, but very recently, exciting news from the Tanis fossil site in North Dakota.
Tanis. The one linked to the asteroid impact.
That's the one. They reported finding a Thescelosaurus leg there with preserved scale impressions.
Wow. So scales it is then, at least on the legs.
Seems like it. Direct evidence, which is fantastic. It really changes the picture.
It always does. New finds keep rewriting the details. Okay, let's switch gears to how we even know about this neglected reptile. What's the discovery story?
It actually starts back in the Bone Wars, that famous period of intense fossil hunting rivalry in the late 1800s.
The Marsh versus Cope?
Exactly. In 1891, one of Marsh's collectors, John Bell Hatcher, and his assistant found a really good skeleton, nearly complete, in Wyoming, Lance Formation.
A major find.
You'd think. But somehow it got shipped back to the Smithsonian, packed up, and then just sat there, unlabeled, overlooked.
No way. Just lost in the collection.
Pretty much. Forgotten for over 20 years. It makes you wonder what else might be hiding in museum drawers, you know?
Absolutely. So who finally rediscovered it?
That was Charles Gilmore, a paleontologist at the museum. In 1913, he opened this old crate, found the skeleton, realized it was something new, and described it.
And named it Thescelosaurus neglectus.
Precisely. Giving it that perfectly fitting name, reflecting its history right there in the museum, he made that Hatcher specimen, the type specimen, the official example for the species.
Incredible story. From neglected in the field almost, to literally neglected in a box.
Yeah.
Did more finds follow after Gilmore's work?
Oh yes, thankfully. Once scientists knew what to look for, more specimens started turning up. Across western North America, actually.
Whereabouts?
Places like North Dakota, South Dakota, Montana, up into Alberta and Saskatchewan in Canada, found in formations like the Hell Creek, the Frenchman, the Scallard Formation. So it was pretty widespread at the very end of the Cretaceous.
And this led to some taxonomic shuffling, right?
Yeah.
You mentioned T. warini earlier.
Exactly.
Okay.
That was initially named as a Thescelosaurus species in 1926. But later studies showed it was different enough to warrant its own genus. So Charles Sternberg renamed it Parksosaurus in 1937. Then there was T. edmontonensis, named by Sternberg in 1940. But most paleontologists now think it's probably just another T. neglectus It's an enemy, we call it.
Right, and the Biganosaurus situation.
Yeah, Dinosaur infernalis was named in 1995, thought to be distinct, but later analysis folded it back into Thescelosaurus as T. infernalis. Though, like we said, that species itself is now considered dubious, a nomen dubium.
It really shows how science is always refining things, reevaluating the evidence. It's not static.
Absolutely not. It's a constant process of discovery and interpretation.
And speaking of discoveries, tell us about the Willow specimen. That one got a lot of press.
Ah, Willow. Specimen number NCSM 15728, found in 1999, I think. An amazing find, nearly complete skeleton, beautifully preserved skull.
And the heart.
Right, that was the big initial claim. There was this dense, sort of heart-shaped lump, a concretion, in its chest cavity. The researchers who found it suggested it might be a fossilized heart.
A dinosaur heart. That would be incredible.
It would have been revolutionary. It led to the nickname Dinosaur with a heart of stone. But further studies cast a lot of doubt on that.
How so?
Detailed CT scans and chemical analysis showed it didn't really have the internal structure or composition you'd expect from fossilized soft tissue like a heart. The consensus now is that it's almost certainly an ironstone concretion.
Just a rock.
A naturally formed mineral lump, yeah. Formed after the dinosaur died and was buried. Still, Willow is hugely important because its skull was so complete, it showed the head was actually longer and lower than people had thought.
So even without the heart, it provided crucial information.
Definitely. A very significant specimen.
And what about T. acinoboensis? That's a newer name, right?
Relatively new, yeah. The fossil itself was found way back in 1968 in Saskatchewan, but it wasn't formally named and described as a distinct species until 2011.
Why this delay?
Sometimes fossils just take a long time to get studied properly. It's based on a smaller individual, and it does have some unique skull features suggesting real diversity within the genus Thescelosaurus.
It's amazing how long these stories can take to unfold. And you mentioned the Tanis site earlier, too.
Yes, that's very recent and potentially groundbreaking. Finding Thescelosaurus remains there at a site that seems to preserve the moments right around the Chicxulub asteroid impact.
It potentially puts Thescelosaurus right at the scene of the extinction event.
Exactly. It offers a potentially very direct link to the cataclysm that ended the age of dinosaurs, a sobering thought.
It really is. Okay, let's shift focus to how Thescelosaurus lived. It's paleobiology. What was on the menu?
Well, based on those leaf-shaped cheek teeth and the narrow snout, it was definitely an herbivore, a plant eater.
Any idea what kind of plants? Was it picky?
The teeth suggest good grinding ability, and the narrow snout might mean it was a selective feeder, not just mowing down everything, but maybe picking specific ferns or cycads or early flowering plants.
Interesting. So maybe avoiding competition with other herbivores.
Quite possibly. You had other plant eaters around, like the dome-headed Stegosaurus. Maybe Stegosaurus ate tougher stuff, and Thescelosaurus focused on something else. Niche partitioning, we call it. Helps multiple species coexist.
Makes sense. How about getting around? We know it was bipedal, sturdy, not a sprinter. But was there debate about its agility?
There was. Gilmore, who first named it, initially thought it was quite agile, maybe even slender.
But Sternberg disagreed.
Yeah, Sternberg looked at later finds and argued for a much more robust, heavily beat animal not really adapted for speed, and the leg bone proportions, that longer femur, seemed to support Sternberg's view more.
So probably not darting around.
Probably not. Someone, Peter Galton, even floated the idea it might have occasionally walked on all fours, given its fairly long arms and wide hands.
Quadrupedal.
It was suggested, but most analyses since then think that wouldn't have been very efficient. Bipedal seems the way to go, although some recent work suggests maybe it wasn't super slow either. Certain muscle attachments and features of the inner ear related to balance hint it might have had reasonable agility, just not top speed.
A nuanced picture then. Not a racer, but maybe not a plotter either.
Something like that.
You mentioned the inner ear and balance. Does that tie into anything else, like that burrowing idea?
Yes, the burrowing hypothesis. This is really intriguing. Studies of its brain cavity suggest it had a pretty good sense of smell and good balance, but maybe its hearing wasn't great.
That combination is seen
In some modern animals that burrow. Plus, we know a close relative, Oryctodromeus, definitely dug burrows. We found its fossils inside them.
Wow.
And Thescelosaurus has some features that could fit with digging, too. Robust arms, fused bones in the snout for strength, broad shoulder blades for strong muscle attachments.
So the anatomy seems consistent with digging.
It seems plausible, yeah. Even its size wouldn't rule it out, so maybe it spent some time underground, for shelter or protection.
A burrowing dinosaur. That's a fantastic image. Changes how you picture it. Did they live alone or in groups?
Good question. The brain was relatively small for its body size, which sometimes suggests simpler social structures.
Less complex behaviors.
Possibly. The thinking, partly based on comparisons with Eryctodromius again, is maybe small groups, like just 2 or 3 individuals, maybe family units. But direct fossil evidence for group size is pretty scarce for the Thescelosaurus.
Okay, so maybe small family groups potentially living in burrows. Fascinating. Now we have to revisit the heart. Can you just quickly recap why it's probably not a heart?
Sure. So the Willis specimen had this lump, this concretion. Initial study suggested it might be a fossilized 4-chambered heart, implying high metabolism, like birds or mammals. Huge news.
Right.
But later, more detailed studies using CT scans and looking at the minerals just didn't find the evidence. No clear chambers, no muscle tissue structure, wrong mineral composition for fossilized soft tissue.
So the scientific consensus shifted.
Overwhelmingly, yes. It's almost certainly an ironstone concretion, a geological feature that just happened to form in roughly the right place and shape. A cool rock, but not a heart.
Science in action, correcting itself based on evidence. All right, let's zoom out. Paleontology. When and where exactly did Thescelosaurus live again?
It lived right at the end of the late Cretaceous period. The final stage, called the Maastrichtian, we're talking roughly 66 million years ago.
This is among the very last non-avian dinosaurs.
Absolutely, just before the big extinction event. And its fossils are found across western North America, Wyoming, the Dakotas, Montana, Alberta, Saskatchewan, places covered by formations like Lance, Hell Creek, Frenchman, Scholard.
Got it. Was it common back then? Or rare?
Historically, people thought it was fairly uncommon, compared to the hordes of Triceratops or Edmontosaurus fossils.
Right.
But more recent studies suggest that might just be collection bias. Maybe paleontologists tended to focus on the bigger, more spectacular finds. Some analyses now suggest that Thescelosaurus might have actually been quite abundant. Maybe even one of the most common dinosaurs in certain areas, like the Frenchman Formation in Canada.
Wow. So its neglected status might have continued even in how we counted it.
Could be. Perception is changing. It might have been a really key part of that late Cretaceous fauna.
What was the world like then? What kind of environment are we talking about?
Think coastal plains near the western interior seaway, that big inland sea that split North America. The climate varied, maybe semi-arid in some places, more humid in others.
Lots of rivers.
Yeah, braided streams, meandering rivers, floodplains. In places like southern Saskatchewan, it seems to have been subtropical or warm temperate. Swampy forests, lots of conifers, but also flowering plants were diversifying. And there's evidence of wildfires, too.
A dynamic landscape. Who else lived there? Who were its neighbors?
Oh, a star-studded cast. You had the giants like Triceratops, Edmontosaurus, and of course Tyrannosaurus rex.
The big name.
Yep. Also smaller ceratopsians like Leptoceratops, various pachycephalosaurs, the domeheads, and armored ankylosaurs. And plenty of smaller predators too, dromaeosaurs, the raptors, and troodontids.
So Thescelosaurus was living alongside all of them.
Exactly, a very diverse ecosystem. And Thescelosaurus itself, being a medium-sized herbivore, was probably on the menu for things like smaller tyrannosaurs or the larger raptors.
A tough world to live in.
Definitely.
Okay, finally, let's circle back to its classification one last time. It sounds like figuring out exactly where the Thescelosaurus fits has been tricky.
It really has. Early on, it got lumped in with groups like Camptosauridae or Hypsilophodontidae based on general similarities.
But those groups have changed.
Big time. Hypsilophodontidae especially used to be this kind of catch-all bin for small ornithischians, but it's not seen as a natural group anymore. Sternberg recognized the Thescelosaurus and Parksosaurus were distinct enough to need their own family, Thescelosauridae.
And that family is still considered valid.
Generally, yes. Thescelosauridae is widely accepted now, often split into 2 subfamilies, Thescelosaurinae, which includes Thescelosaurus, and Orodrominae, which includes Eryctodromius, the burrower.
Okay.
But the big question remains, where does Thescelosauridae itself fit? Are they basal ornithopods, like we mentioned earlier, or are they something else, maybe branching off before the main ornithopod radiation within the larger Neornithischia group? Different studies still give different answers.
So the puzzle continues. Even its fundamental position is debated.
It is. And the fossil record for the earliest Thescelosaurids is a bit patchy. They seem to go back quite a way, maybe Middle Cretaceous, suggesting a long evolutionary history, a ghost lineage, before Thescelosaurus itself appeared right at the end.
A long history we're still piecing together.
Exactly. The split between those two subfamilies seems to have happened in North America quite early, maybe early Cretaceous. It's a complex story spanning continents and millions of years.
Wow. Well, that brings us towards the end of our deep dive on Thescelosaurus. It's definitely lived up to its marvelous reptile name.
Absolutely. From being overlooked in a museum box
Yeah.
to potentially burrowing underground and being right there at the end of the dinosaur era, it's a fascinating creature.
It really offers this unique window into the late Cretaceous. So many layers, the discovery history, the paleobiology debates, the classification uncertainty.
Mm.
And I guess that leaves us with a thought for you, our listener, given all these ongoing questions, especially about how it lived and where it fits in the family tree.
Yeah. What kind of future discovery do you think might be the key? Maybe finding one inside a burrow like a Rictodromeus, or perhaps finding more skin impressions or even rarer soft tissue evidence. One might finally pin down the true nature of this marvelous, sometimes neglected reptile and its role in that lost world.
Something to ponder. The story is clearly still being written.